I'm coming! Almost there, Sherlock! What's your problem this time? What are we doing in this wonderful city? I mean, well, you know, Watson, I'm really confused by developers. I looked at a few conferences schedules, you know, and it seems that they're only interested in the latest trending tools and technologies, frameworks, etc. I don't see the problem. I mean, it seems logical to get interested in the latest news of your own domain, right? Yes, but nobody is interested in the old stuff anymore. Everybody's missing the greatest investigation of all time. Which one? HTTP, of course. I mean, you know nothing, John Watson. Everybody's using them, but nobody really knows how they work. Everybody's forgotten about the history, how they work. I mean, it pushes lots of developers to make silly mistakes on web projects, but also I noticed that muggles, you know, non-IT people, started to have a profound lack of knowledge and care regarding privacy and tracking online. So I asked Hubert SABLONNIÈRE to investigate. Français? Yes, but I mean, how do I say that? He looks a bit like us, doesn't he? So I asked him to do a back to basics kind of talk and to really insist on the facts, just the facts. So that way anyone, depending on their own context, so personal and professional, can detect some of the problems and take the right decisions. I'm intrigued. Hello everyone, my name is Hubert SABLONNIÈRE. I'm a web developer at Clever Cloud. Who knows Clever Cloud? Okay. Try to visit the website afterwards. We are a PaaS company, an IT automation company. The idea is that you do a git push, we take your code, we build it, we deploy it in production, and then we maintain all the stack on which your code runs, the OS, etc. Ask any questions afterwards. I'll be there until tomorrow. So today I want to talk about my investigation on HTTP cookies. And so I started to go back at the root of the cookies. The year is 1994. And I got interested into that man, Lou Montulli. So when you start to look at the history of the web, you get articles about Tim Berners-Lee, obviously, Robert Cailliau. But today I'd like to honor Lou and emphasize all the impact he had on many web technologies that we are still using nowadays. So here we go for the anecdotes. So back in 1994, Lou was working at Netscape, and with his colleagues, he was one of the people responsible for the second, almost second live webcam of the web. And so basically, it was just fishes live from an aquarium, and right now we can still have a look at the fish cam online on fishcam.com. So, hey, little fishes. Well, it downloads like 20K every 2 seconds, so I'm gonna shut it down. What's nice is when you rehearse and there's the cleaning guy behind the aquarium. Anyway, so he also participated in the creation of Lynx. So Lynx is a text-based web browser. So it's pretty nice, actually. So I can visit, obviously, my own website. And it's just text. It loads crazy fast. I can navigate stuff, fill in forms, etc. Go to Clever Cloud website. When I don't really use it every day, of course. But what I really like is that it really puts back the emphasis on contents and accessibility, which is something we often forget. So about Lynx, Lou created Lynx, and during a summer, so with his colleagues in 1994, he went to a bar, and they were discussing, you know, the latest technologies back then that they were about to put in Netscape. So latest, you know, news about HTML, tables, images, etc. I mean, crazy, right? And they were talking about more advanced stuff, and Lou was sad. He was like, man, I mean, on Lynx, I don't have lots of areas to improve stuff. It's just a terminal, so maybe we could make some text blink? right? I mean, they had a really good laugh about the fact that this idea was completely stupid. And so the evening goes on. Lou will meet his future wife, anecdote. And he goes back home, and then he arrives in the morning at the office just to realize that his colleague, like, you know, first degree John, went back to the office during the night to implement the best HTML tag ever, right? And could have been worse if they asked for my opinion back then. So we're making fun of it, but I mean, we all use the blink tag, right? Yeah? Lots of liars here, yeah. Or young people, I don't know. So yeah, back then everything was good to take the attentions of the users, the visitors, to take their attentions to see the banner ads. So we had blinking text, we had Java applets in 1995, and Lou was, again, he was a bit, you know, puzzled, sad. He said, well, the Java applets takes like 30 seconds to load just to, you know, animate text and be like, buy my dishwasher or something, you know. So he really poked his colleague, forgot his name, Scott Furman, which was in charge of the imaging, and he said, Scott, we have to do it. And so what they did is that they took the GIF format and they added an option which is still today called the Netscape application block. And actually, they just added this option to loop an already existing set of frames in a GIF format. So if nowadays we have never-ending loops of GIFs, it's because of Scott and Lou. GIF. GIF? Okay, I'm gonna say GIF. So now you understand what I was talking about, right? GIF. If I talk so much about Lou, it's also and mainly because he's the inventor of HTTP cookies. And back then, the web was pretty much stateless. So when you wanted to, you know, implement an e-commerce website with a virtual cart, while maintaining a visitor connected, while doing many page refreshes, you had to get up early. It was pretty hard to do. And so that's exactly why Lou invented cookies, adding some state on the client to maintain someone connected. Sorry, yeah, so during my investigation, I tried to look at many points of view, and today I will mainly focus on the point of view of those who use cookies on their website. So we're going to ask a few questions, do some recaps, but recaps are always good, right? I saw, like I said, a lot of misuse of cookies, so it should be good to have some reminders. We'll discover a few novelties, and that's it. We'll see a few other point of views. So first question, what is an HTTP cookie? And so first we'll start by avoiding, you know, the typical definition of cookies we see in the muggles media, you know, like, those are tiny files stored on my computer. Yeah, no. This definition is outdated and it's incomplete. Thinking that cookies are just a storage mechanism. It's really more than that. We've been storing them one per file since like i7 or something. And it's not only a storage system. The other thing we're going to stop saying is mixing up user sessions and cookies. I saw too many projects where a colleague were like, I put that information into the cookies. Now I looked at the cookies, I was like, oh, you mean you put it on the server side in the user session? And he was like, it's the same. No, it's completely different. I mean, so something is on the server side, the other thing is on the client side. And I know I'm picky, but I really want you to make the distinction. So the way I like to define the cookies is it's more of a protocol, you know, like something on which servers and browsers agreed upon to maintain a state on the client side. Small diagram, small diagram. So let's take a user. He wants to visit cookies.rocks. By the way, I bought this domain, so if you want to donate to my Patreon, feel free. So the user visits this website, wants to visit the website. So the browser is just doing an HTTP GET to the server, and then by doing an HTTP GET, the server will answer with a classic 200 OK with the HTML content, but the server can say, I'm giving you some information with the HTTP header set cookie. And yes, that information is mostly here to convey a session ID, but it's different. We can also pass anything we want. It's just a key value, so maybe the language set up by the user, a theme or something like that. So now that this browser has received this information, it has a cookie jar. Yummy, but it's really the name in every browser sources. So in the cookie jar, it just puts the cookie, it takes the cookie and put it in a jar. And then when the user wants to visit the same website again, the browser just follows the protocol and looks into his cookie jar and is like, is there any cookies for this site? Yes, of course, there is. So the browser then, following the protocol, takes the cookie, does the same HTTP request, but now uses the cookie header to send the information back. And yet, in our example, it's still an ID, sorry. With that, the server can say, okay, I'm sending you the HTML, but now I know you are user 42, for example. Okay? Cookies are nothing more than this. A protocol between servers and browsers, allowing the storage of state on the client side. This behavior was invented by Lou, as I said, in 1994. Netscape did a small spec, small draft, so anyone could agree upon the same behavior. They filed a patent, so what's really nice is that we can still see it on the web. So inventor, Lou Monturi, original assignee Netscape, current assignee. Okay, moving on. True story. There has been two RFC following that, so in 1997 and in 2000. And we'll see the rest afterwards. So next question, how long a cookie is stored? Well, basically, if you just, so as a server, say, set cookie ID 42, it will last until the end of the session. So while the browser is still open, but with hibernation on laptops, etc. Sometimes we keep open our browser really long. So a server can say, I'm giving you a specific date. This date is really important. Americans here? No? Okay. With the attribute expires. Or you can use a value in seconds with the attribute max age. With this, you are saying with the server, hey, I'm giving you this, but until this duration or date, just remove them. Once you set something on the client side, how a server can delete a cookie, or more exactly, how a server can request a cookie deletion. Because, I mean, the server can't delete the cookie. It can just ask for the client to delete it. So at first I was like, there must be a header like remove cookie, delete cookie, right? No, there's set cookie in the past. So we often use the value of the Unix epoch date, obviously. And you can also set a max age of 0 seconds, so here. So for now, things are simple. No surprises, no traps. But since the beginning of the talk, I've been saying when the user goes back to the same website, the browser has to send the cookies. What does it mean the user goes on the same website? How does the browser know that those two URLs are different? Spoilers, they are. It's not the same website. But it's obvious for us, right? What are the rules for a given browser to identify that those websites are different? And with that, we are really touching the main problem with cookies. It's really hard to know when the browser will automatically send cookies according to the protocol when a request is leaving the browser. So for that, we're gonna take more interest in URLs, and I love URLs. So in URLs, I have a cold, so my voice is a bit too. I love URLs, you know. Sorry. So in URLs, we have a protocol. We have a host, a port, and a path. Okay. I'm gonna do it again because I spent like 3 hours doing this. A protocol, a host, a port, and a path, okay? And on those different parts, the browser will check stuff depending on attributes of the cookies we already saw, expires and max age. We'll see other ones that will handle different parts of the URLs. And the first problematic attribute, I mean, it's the most problematic one, is domain. So if I set a cookie ID 42 with domain equals cookie.rocks, cookies.rocks, you're like, what does it do? At first I was like, must be a way to say to the browser, this is only for cookies.rocks. And so if you take if you are on cookies.rocks and you send 2 headers, like something without the attribute domain, the domain attribute, and one with the domain attribute, which is exactly what's in the address bar, I was like, must be the same, right? So we're going to check what that does with the demo, and we'll also be adding 2 other headers. So some with subdomains blue and green here. Okay? So let's give this demo a test. So we are on cookies.rocks. It's hosted on Clever Cloud, obviously. You can try it afterwards. There will be lots of demo here that I won't have time to do it now. So let's click on the domain attribute. What I just did by visiting this page is that the server set 2 cookies, and one with the attribute, as I said here, and one without, okay? And so first I was like, it's the same, right? It's exactly the same except 1 pixel, or 9 pixel in HD, or something like that. So the difference is this dot, okay? And it's not only this dot, because when I added this domain, if I go maybe to a different subdomain, so let's go to blue.cookies.rocks and show the cookies. The cookie that was set with domain equals is sent, but the cookie without the attributes was not sent, okay? So that means there is a difference, and actually when I do nothing, when I just don't put the domain attribute, the cookie will be validated on the whole host. But when I add domain, I actually increase the range of the cookie to all hosts ending with the value. I had to repeat that sentence twice in my head. It was completely different from what I had in mind. So let's do examples. If I am on blue.cookies.rocks and I don't use the domain attribute, which is something you should almost always do, don't use it, only the URL matching the exact same host will be sent with the cookies. If you had the exact same address, blue.cookies.rocks, everything ending with blue.cookies.rocks will be sent with a cookie too. So any subdomain like big.blue, you see the point. So then if I only say domain equals cookies.rocks, more URLs will be sent with the cookies because they all end with cookies.rocks. Make sense? So then I was like, hey, what if I say domain equals rocks, or com BEFR, etc. Can I set a cookie on the top level domain? No, and that's a good thing, right? So if we look closely on a host, we have the subdomain, not supposed to be in French, sorry, the domain and the top level domain, the TLD. And so browsers should have a way to detect that someone is trying to put a cookie on the TLD, and you should not do that. So, you know, URLs 101, just split after the last dot, right? What about our friends across the channel? I mean, in the UK, they have 2 dots in their TLD. So how does it work? And in my investigation, I stumble upon a few issues. So in Mozilla, in like 15 years ago, they were like, okay, someone can put cookies on .co.uk, it's a problem. You can obviously remove them or even replace them, which is a problem. So then there has been a few discussions, like we need some knowledge about subdomains, etc., or even having some kind of list of all the top-level domains. Then the discussion went to a dedicated page, and it ended up on its own website nowadays. So this list contains lots of top-level domains. It's even advised in the latest RFC about cookies. So in the RFC, they say you should use publicsuffix.org list, etc. So if you look at the sources of Firefox, they use the list. If you look at the source of Chrome, they use the list. If you look at the source of Safari, they are using a library which in the end uses the list. If you look at the sources of Edge, anyway. So in the list, there are top-level domains, as I was saying. But while I was investigating, I was like, man, there is lots of other stuff, and there is actually private suffixes. So when you host something on GitHub, Amazon, Azure, GCP, etc., your browser actually contain rules from that list to prevent you from setting domain cookies on like domain equals github.io, which is a good thing. But you weren't aware of that before entering the room. Now you're safe, right? And so there are lots of them. Obviously, at Clever Cloud, we have a temporary domain just like the other hosts. So we are in the list too. So basically, the idea is just to think about not TLD, but public suffix. Okay, for a complicated reason, you can't do domain equals localhost to like set a domain for any subdomain of localhost, but it's not in the list. So no, you can't do that. So next attribute. This one is simpler. You can say path with slash something. There's a small trap. I mean, if you don't say anything, any URL will match. If you say path equals API, anything starting with /API will be sent with the cookies, or not, because here we have /API-FAQ. So it's a bit more subtle. It's like slash something slash. You know, it matches with a real part of a path. So my definition would be like it restricts the range of a cookie to a path that starts with the value and small detail. Don't use that for security reasons. I mean, most of the time, setting the attribute to slash is just okay. Don't be like, I'm super secured. I put /API and it works really well. It's not really a good thing to do. So, imagine we are on HTTPS right now. Look at the URL. We are in a secure area, right? Loud voice. So every request will be sent with the cookies, even unsecured requests. So you are at home, you connected to awesomewebsite.com in HTTPS. You go into a cafe, you know, those cafes where they have free Wi-Fi. Or, you know, airports, like, hey, I'm injecting you in the page the times of your flight. Awesome. Freaking. Okay. So if you visit unsecured pages and you have cookies, they will be sent. So something was added really early on, which is this secure attribute. If you put this, basically only the secured request will be sent with the cookies. That's nice. So secure attribute restricts the range. You have another way to prevent your browser to leak cookies for when you do unsecured request, which is the HSTS header. So the idea is that as a server, you can say to your different browser clients, I'm giving you this cookie, and we are talking in HTTPS, but never talk to me in HTTP. So that means the browser will like store an information like this awesome website will never go to it in HTTP. So if you type the URL, if you follow a link, the S will be automatically added, if I could say it like that. It's not that easy. Don't add it like Hubert told me to add it, it works. No, it's a bit more subtle. So read this page, hire security professionals, as always, but this header exists. Small detail, if you are on a non-secure URL page, you can set cookies with the secure attribute, again, which is a problem. So there have been a few drafts from Google to restrict the secure attribute to secured requests. So Chrome is implementing it and Firefox too. I hope the other one will do it. Okay, so we've been setting a lot of cookies, but when you are a server and you receive a cookie, you only see that. You only have the key and the value. You don't know if the cookie you are receiving was sent on a secure channel with a domain attribute or something. So in the latest draft, ta-da, there's some news in the cookie land in 2017 and 2018. In the new draft, we have two new features. The first one is prefixes. You should smell the hack, because we don't have a great way to change cookies. I mean, there are like zillions websites out there. So the idea is that you set a name for your cookie that starts with __secure. A bit hacky, right? And when you do that, you have to use the secure attribute. So when you do that, the browser will look at the request and say, okay, is this a secured request? Is there a secure attribute? If so, I'm storing it, and I will only send it on secured request. Okay, so that's pretty nice. It's like adding some, I always forgot the word, the suspenders, right? Then you have __host, which is even better. It's like belt, suspenders, airbag, all protections. When you say that, the browser will receive the cookie. It will look if there's a secure attribute, if the path attribute is /, and it will check that there is no domain attribute. So cookies are only matched on the full host, no subdomains bullshit, you know, only the host. So __host is like really a really nice protection to set cookies in modern browsers. So we've been looking at the protocol, the host, the port, the path. We've seen that secure plays on the protocol. Domain, you should not use it. Will handle matching on the different parts of the host. We've seen the path attribute, which is not that interesting. What about the port? Is there a check on the port? Right now, you should be sensing the next slide, right? No. And that's the last problem, I would say. It's not a big one, but a few years ago, we had like the staging environment on port 8081 and the production on 8082 and the beta on 8083. And so every cookies were mixed up, but we've all stopped doing that in internal application, right? Yeah, I hope so. The problem is everything in the browser, almost everything is restricted by the same origin policy, AJAX requests, setting local storage, etc. Everything is following this rule. And so an origin is actually the combination of those three parts. If two URLs, two websites have the same protocol host and port, it's the same origin. And cookies, of course, are matching on this, which is frustrating. But right now we are forced to have that kind of behavior. Someone tried to put a draft and say, hey, let's stop everything. We're going to change from the cookie header to maybe origin cookie. Everyone is ready to update in 1 month, 1 week, right now. Doesn't work on the web. You can't change everything like that. So that draft hasn't really taken off. So let's take our example back. We are in a browser land, and right now we want to go to example-foo.com. Remember my Patreon? It's the second domain I bought. If I want to go on this website, the browser says, okay, we're gonna make a request. The server answers. We are now on example-foo.com. Okay. Now, if on this website there's an image, maybe on cookies.rocks, a JPEG image, the browser will do the request. But what is a browser? It's a software that follows the cookie protocol. So it looks into the cookie jar. Is there any cookies for cookies.rocks? Yes, there is. The user has already visited this website and maybe logged in. So I'm going to send the request to this image, which is on a different website, and send the cookie, like the cookie. And that's what creates lots of problems. It's actually the reason we have like CSRF attacks or also called XSRF attacks. I'm going to do a small demo. So maybe I'm going to clear the cookies. Okay. I'm going to go back on cookies.rocks. I'm going to go to my profile. So my name is Hubert with an H and a T, SABLONNIÈRE. It's really important. I update my profile, and right now I'm connected. The informations are stored in the session on the server side, and each time I refresh the page, the browser is sending some kind of identifier. So here it's like 1S, blah, 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 it's a random string. So each time I'm doing a request, I'm sending this cookie, and the server knows I'm Hubert. So now I'm going to go to a different website, so example-foo. Ooh, interesting links, right? So maybe I want to see naked pictures of foo, right? We don't even know what is a foo, but anyway. So I'm going to click here. What my browser just did is to do a request on, on the web page here, but also on cookies.rocks/update profile. Whoa, strange URL for an image, right? It's actually broken. But what my browser did was, I'm a browser, I send the cookies, so I just send the cookies for cookies.rocks, which is the identifier. And so I also send some stuff. So if I go back to cookies.rocks on my profile, my name is now no naked pictures, sadly. Okay, so this is clearly what we call an XSRF attack. But no one modifies the state on the server with a GET request, right? Okay. This can also be done with a post. I'll let you do the demo. And you'll have to click on I want to become rich right now. really works well. But it works too. It will work with a simple form post from a different origin for XHR AJAX request. It's a bit more subtle, and I won't go into the details right now. CSRF attacks are really complicated. Hire professionals, read that page like many times, and you'll get the gist of it. Most of the time, you should have the tooling in your frameworks with, CSRF tokens, etc., to prevent such attacks. And there is the second new features of cookies in the latest draft, which is called SameSite attribute. It's a new attribute. So you have two values. I won't go into the details. It's kind of complicated. But the idea is that you are on cookies.rocks, you set a cookie with this attribute, and it tells the browser to don't send it if you're not on my site, if you're on a different site. So for the examples I shown, it wouldn't work. When I started the talk in March, it was only in Chrome. Right now it's in Chrome, Safari, Firefox, Edge, and even IE 11 on some Windows 10 something, which is pretty nice. I suspect that the update was a bit pushed by this incident at Twitter, because even if you have a CSRF token, there are many ways to, if you make someone browse a Twitter profile and this profile is blocked, the request will be really fast, but if you know that person, the request will be longer. So with that kind of timing attacks, you can try to be a bit clever. And if you read this article, it's like amazingly clever how people tracked users using that technique. So with this attribute, we are safe. So who can read the cookies? JavaScript, yeah. With the craziest web API ever. I mean, if I go back to cookies.rocks, I just have to open a console, do document.cookies.cookie, yeah. Why? I don't know. You have a key and a value, so maybe I'm like, okay, I'm gonna remove them, right? Yeah, does it work? No, it doesn't. Why? Crazy. Wait, actually, what's interesting is that this property works just like the set cookie and cookie header. So if you set a value with equals, it's just like a set cookie. So you can say ID equals foo, and then max age equals 0, and then I remove the cookie. Don't do that with your own code. Just use a library. It's so crazy. If JavaScript has access to cookies, it means you are open to XSS attacks, so cross-site scripting. Could have been CSS, but CSS is another thing, and it's awesome, right? So again, CSS attacks, I won't do the demo. There is like many ways to prevent them, and yet it's still a really common vulnerabilities on websites. So read that, hire a professional, do audits, also look at CSP. But on the cookie land, you have an attribute called HttpOnly. And this attribute is kind of great. It's a way to send a cookie and say, don't give it to JavaScript, please. Okay? So when you do that, you renounce on the capability of reading your cookies from, Angular, React, or something. But it's really better because anyone can inject a script in your page if you are not using HTTPS, but you are using it. If you have vulnerabilities on forms, like I put, but you protected them, right? Or if you're including dependencies. Anyone has read the code from React, Angular? They are great, those frameworks, but when you take a library to manipulate dates from, John or Catherine that does that on the weekend, maybe you don't know what's in the code. So again, use the right tool to identify vulnerabilities, even if in the JavaScript you include in your apps that you don't really know about. With this, they won't have access to the cookies. So some recaps. We've seen lots of attributes. Expire, max age, domain, path, secure, HttpOnly, and SameSite. There's a really interesting article from Scott Helm called Tough Cookies, which is kind of a recipe of good cookies for the web. And so you use prefix __ host. You use the attribute expire, of course. Use path / mandatory for __ host. Secure, HttpOnly, and SameSite. Best cookies in town, okay? So I'm gonna just show that. Read the article. Picture time. Yeah, no, sorry. Okay. But yeah, this is the best cookie you can have. If you have questions on should I use cookies or local storage, come look at me after the talk. It's a bit long to explain. I want to finish with another point of view, which is the point of view of those who want to improve the user experience, of course. Who wants to improve the user experience, right? Okay. So I want to improve the user experience of my visitors, right? So I'm going to use cookies differently. So let's do a demo. I'm going to clear the cookies. Okay. I'm going to open two websites, example-foo.com and example-bar.com, another domain. Okay. So again, really interesting web pages. So I'm going to maybe visit the sex position foo. Maybe I have a disease, something I don't want anyone to know. I'm going to visit those. And then after that, I'm closing the tab. And I mean, we've all seen the Mr. Zuckerberg. If I close the Facebook website, can you still track me? Well, you see, Senator. Yes, the answer is yes. So if you click here, I can see the two pages I just visited on two different websites. Crazy, right? But it's that simple. And when I wrote the demo, I was like, ooh, I feel dirty, right? But it's really that simple. So let's have a look again at example-foo. If I do a refresh, so actually, sorry, if I go to this page, if I look at the bottom, I just have an image, which is on cookies.rocks. So if I look at network, there's actually a request to cookies.rocks /cookie.svg. And so now you should know that the request was sent with a cookie with my identifier, which is me. But it was also sent with the referrer, which is the complete URL of the page, the current page. Basically, most advertisers are relying on JavaScript, so they are getting the full address from JavaScript. But if you disable it, they will be able to read it with the referrer. Yeah, we improved user experience. What's nice, and I'm going to finish with this last demo, I'm going to delete the cookie, and then I'm going to try to disable the cookies. So, okay, let's check. So we could disable the third-party cookies. So third-party cookies are just cookies that are sent from site B to site B while you are on site A, for example. So just like I did. So I could, block only third-party cookies, etc. I'm gonna block all cookies. Okay, great. Let's try again. So yeah, I'm gonna delete the cookies. Go to bar. It has Comic Sans. Okay. I'm gonna try this one because I hate bar. It's the worst actor of Hollywood. And here I have a different image. And this image, like many images on the web, was sent with an e-tag header. So an he tag is the way for a server to say, I'm giving you this image, the checksum is 42, blah, blah, blah. If you go back, just give me the checksum, and if I have the same in the backyard, right, on the server, I'll just tell you 3 or 4, you have the right version. Okay, so we just sent information that the browser registered. Classic way to do tracking. So I can put anything but a checksum. So here I'm sending, where is it? E tag. So here I'm reusing the same ID that was sent the first time, so without cache. Here. Where is the he tag? Where is it? Here. So it's a basic random string. So with that, I'm able to go back to cookies.rocks and see tracking image with he tags and see the visited pages. Okay? Cookies are blocked, every cookies. And that's one of the many ways to track people without cookies. There are so many, and so it's a bit, at least it's freaking me out. Maybe you, I'm not sure. Anyway, so you have a way as a developer to block referrers. It's interesting, you should do it, but it's not like a perfect protection. I'm gonna end with my conclusion. Yeah. So basically, am I finding my conclusion? Yeah, I am. Basically, 24 years later, we've come a long way, right? And since then, we've been complaining about cookies a lot. There are limitations, they are misused by developers, and yet, with my investigation, I have to ask the question, would we have the open web we have right now, standard World Wide Web, without all those banner ads and blinking text everywhere? And, you know, those really annoying GIFs. I mean, the web also spread because lots of websites relied on free content and advertising revenue, and people visited those websites because it was free. So as long I don't really like ads just like you, but it's also one of the reasons the web really took off instead of a CompuServe or AOL proprietary competitors. So nowadays users are really fighting online ads, blocking with extensions, also blocking trackers for privacy reasons, and browser makers have been, like Firefox or Safari mostly, are putting lots of efforts to protect your privacy, and they have to face the fact that we are all in the middle of an endless race, an endless technical battle or fight against advertisers. It's more of a cat and mouse game, you know, that should also be played maybe on the non-technical side with citizen debates and legislation. Wow, that was a lot of facts. Indeed, my Sherlock. Yes, but you know, Watson, with all those facts, we have everything we need to understand cookies and know when it stinks, you know? When there's maybe vulnerabilities or something. With all those facts, we have everything we need to spread the knowledge to our family and friends, the muggles, right? And with all those facts, we absolutely must start to debate the economics and how the web works. And we can't rely, you know, having everything for free, blocking every trackers and ads. I mean, at some point we'll have to choose or decide for different models and different ways. Thank you very much.